Hello students, last class we studied the synopsis of the chapter probability. So in this class we will discuss a few of the problems related to the chapter probability. The first problem is, let A and B be two events if probability of A is equal to 0.2, probability of B is equal to 0.4, probability of A union B is equal to 0.6, then probability of A given that B is already occurred is. So we know the formula to find probability of event A given that B is already occurred. It is equal to probability of A intersection B upon probability of B. So this is the formula to find probability of A bar B. But the given probability of A value, probability of B value, probability of A union B. From that given three data, first we need to find probability of A intersection B. We know that probability of A intersection B, it is equal to probability of A plus probability of B minus probability of A union B. So this implies probability of A value they given 0.2, probability of B value they given as 0.4 minus probability of A union B, it is 0.6. 0.2 plus 0.4 is 0.6, 0.6 minus 0.6 is 0. That is probability of A intersection B, it is equal to 0. So final answer is 0 upon probability of B value is 0.4, 0 by non-zero is 0. Therefore, the correct answer is option D. This is the solution to the first problem. Second question. Second problem, let A and B be two events such that probability of A is equal to 0.6, probability of B is equal to 0.2 and probability of A bar B is 0.5. Then probability of A dash bar B dash is equal to. So we know the formula to find the probability of A dash bar B dash is 1 minus probability of A union B upon 1 minus probability of B. Therefore, first we need to find the value of probability of A union B and also probability of B value. So they given that probability of A given that B is already occurred, it is equal to 0.5. It is nothing but probability of B into probability of A intersection B. It is equal to 0.5, because we know that the formula to find probability of the event A given that B is already occurred, it is equal to probability of A intersection B upon probability of B. So this is the formula. Therefore, we will get probability of A bar B is equal to probability of A intersection B upon probability of B is equal to 0.5. Therefore, probability of A intersection B, it is equal to 0.5 times of probability of B. It is equal to 0.5 into the probability of B value is 0.2. It is equal to 0.1. Then for the probability of A union B, it is equal to probability of A plus probability of B minus probability of A intersection B. We will get 0.2 plus 0.6 minus 0.1, it is equal to 0.7. Therefore, the value of probability of A dash given that B dash is already occurred, it is equal to probability of A dash intersection B dash whole divided by probability of B dash. By using De Morgan's theorem, we can write A dash intersection B dash as A union B whole dash upon probability of B dash. Therefore, probability of A union B whole dash is 1 minus probability of A union B upon 1 minus probability of B. 1 minus probability of A union B is 0.7 upon 1 minus probability of B value is 0.2. We will get 0.3 upon 0.8, it is equal to 3 upon 8. Therefore, the correct answer is option C. Correct answer is option C. But for this problem, please remember probability of A dash bar B dash is 1 minus probability of A union B upon 1 minus probability of B. So, if you remember the problem is in the less steps, we will solve this problem. Next, question number 3. Question number 3. If A and B are independent events such that probability of A and the probability of B lies between 0 to 1, then which one of the following is not correct? First option, A and B are mutually exclusive. Here, if A and B are independent events, that does not mean that A and B must be mutually exclusive. Therefore, the first option is not correct. Let's see the second option. A and B dash are independent. Third option, A dash B are independent. Fourth option, A dash and B dash are independent. That is true. So, we know that if A and B are independent events, A dash B are also independent. A and B dash are also independent. A dash B dash are also independent events. But if A and B are independent events, that is not necessary that both the events must be mutually exclusive. Therefore, option A is not correct. Therefore, the correct answer is option A for the question number 3. For the question number 3, the correct answer is option A. It is not necessary that A and B are mutually exclusive. So, question number 4 and 5, it is not in the syllabus. So, do not solve the problem. Question number 4 and also 5. Next, question number 6. Question number 6. If probability of A is equal to 4 by 5 and the probability of A intersection B is 7 by 10, then probability of B bar A. The formula to find probability of the event B given that A is already occurred, it is equal to probability of B intersection A upon probability of A. We know that intersection is commutative. That means A intersection B is always equal to B intersection A. Therefore, at the place of probability of B intersection A, we can write probability of A intersection B upon probability of A. The probability of A intersection B, they given that value as 7 by 10 and probability of A value, it is 4 by 5. This is 5 ones are 5 twos are. After simplification, we will get 7 by 8. Therefore, the correct answer is option C. For the question number 6, answer is option C. Next problem. Question number 7. Question number 7. If probability of A intersection B is 7 by 10 and the probability of B is equal to 17 by 20, then probability of P of A bar B is equals to. So, we know that the formula to find probability of A given that B is already occurred is probability of A intersection B upon probability of B. So the given probability of A intersection B as 7 by 10 whole divided by probability of B value is 17 by 20. So this is 10 ones are 10 twos are 2 goes to numerator, you will get 14 by 17. The correct answer is option A. For the question number 7, the correct answer is option A. Next problem. Question number 8. Question number 8. If probability of A is equal to 3 by 10, probability of B is equal to 2 by 5 and the probability of A union B is equal to 3 by 5, then probability of B bar A plus probability of A bar B is equals to. So we know the formula to find probability of B bar A and the probability of A bar B. In both cases we require probability of A intersection B. So first we need to find probability of A intersection B. So the formula to find probability of A intersection B, it is equal to probability of A plus probability of B minus probability of A union B. It is equal to the probability of A value is 3 by 10 plus probability of B is 2 by 5 minus probability of A union B is 3 by 5. It is equal to, we will get 3 by 10 minus 1 by 5. After simplification we get 1 by 10. This is probability of A intersection B. Therefore, the value of probability of B bar A plus probability of A bar B is equal to, so when we apply the formula we get probability of B bar A is probability of B intersection A upon probability of A plus P of A bar B is P of A intersection B upon probability of B. We know that intersection is commutative, therefore B intersection A intersection B both are same. We can take both are common, probability of A intersection B into 1 upon probability of A plus 1 upon probability of B. Just simplify the value. Probability of A intersection B is 1 by 10 into probability of A value is 3 by 10, 1 by is nothing but 10 by 3 plus P of B value 2 by 5. After taking reciprocal this will be 5 by 2. We can take 5 as a common, we will get 1 by 2 into 2 by 3 plus 1 by 2. So after taking the LCM we get 4 plus 3 divided by 2 into 6, that is 12. That is answer is 7 by 12. But there is no any options as 7 by 12. Please make the option D as 7 by 12. Answer is 7 by 12. Next problem. Next question number 9. If probability of A is equal to 2 by 5 and the probability of B is equal to 3 by 10 and probability of A intersection B is equal to 1 by 5, then probability of A dash bar B dash into probability of B dash bar A dash is. So again by using the given three values, first we need to find probability of A union B. The formula to find probability of A union B is probability of A plus probability of B minus probability of A intersection B. A intersection B. Probability of A value is 2 by 5. It is 2 by 5 plus probability of B value is 2 by 5. So it is 3 by 10. P of A value is 2 by 5 and P of B value is 3 by 10 minus P of A intersection B is 1 by 5. So after taking the LCM, 10 will be the LCM, we will get 4 plus 3 minus 2. It is equal to 5 by 10, that is equal to 1 by 2. That is probability of A union B. Therefore, 1 minus probability of A union B is also equal to 1 by 2. Therefore, probability of A dash bar B dash into probability of B dash bar A dash is given by 1 minus probability of A union B upon 1 minus probability of B into 1 minus probability of A union B upon 1 minus probability of A. So 1 minus P of A union B is what? 1 by 2 upon P of B value is 3 by 10. After simplification, that is 1 minus 3 by 10 will be 7 by 10 into 1 by 2 upon P of A value is 2 by 5. After simplification, we will get 3 by 5. So again, this is 2 1s are 2 5s are, we will get 5 by 7 into 5 goes to numerator, 5 by 6. It is equal to 25 by 42. Therefore, correct answer is option C. The right answer is option C. This is the solution for question number 9. Next problem. Next, question number 10. If A and B are two events such that probability of A is equal to 1 by 2, probability of B is equal to 1 by 3, probability of A bar B is equal to 1 by 4, then probability of A dash intersection B dash is. So we need to find the value of probability of A dash intersection B dash. By using De Morgan's theorem, we can write A dash intersection B dash as A union B whole dash. Then probability of A union B whole dash is 1 minus probability of A union B. So if you find the value of P of A union B, easily we can find P of A dash intersection B dash. For that, the given probability of A bar B is equal to 1 by 4. The formula to find probability of A bar B is probability of A intersection B upon probability of B. It is equal to 1 by 4. This implies probability of A intersection B, it is equal to 1 by 4 into probability of B. Substitute the value of probability of B, it is equal to 1 by 3. So this implies probability of A intersection B, it is equal to 1 by 12. 1 by 4 into 1 by 3 will be 1 by 12. Therefore, probability of A union B, it is equal to probability of A plus probability of B minus probability of A intersection B. So probability of A value is 1 by 2 plus probability of B value is 1 by 3 minus this is 1 by 12. So the LCM is 12, we get 6 plus 4 minus 1, it is equal to 9 by 12. 9 by 12 is nothing but 3 by 4. It is equal to 1 minus 3 by 4. So 1 minus 3 by 4 is equal to 1 by 4. Therefore, the correct answer is option C. Therefore, probability of A dash intersection B dash, it is equal to 1 by 4. The correct answer is option C. Next problem. This is the solution for the question number 10. Next question. Next question. Question number 11. Question number 11. If A and B are two events such that probability of A is equal to 1 by 2, probability of B is equal to 1, question number 11. If P of A is equal to 0.4, P of B is equal to 0.8 and P of B bar A is equal to 0.6. What is the value of probability of A union B? It is also a very simple problem. They given probability of the event B given that A is already occurred. It is equal to 0.6. The formula is probability of B intersection A upon probability of A. It is equal to 0.6. That is probability of A intersection B, because intersection is commutative, 0.6 into probability of A. We can write 0.6 as 6 by 10 into the given P of A value is 0.4. You can write in the fraction form only. It is very easy to simplify. .6 into probability of A value is 0.4. This implies 0.24. This is probability of A intersection B. So the formula to find probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B. That means 0.4 plus 0.8 minus 0.24. That is 0.4 plus 0.8 is 1.2. It is 1.2 minus 0.24. So after simplification we will get, this is 1.2, 0.24, this is 0, this is 6, this is 9. Answer is 0.96. The correct answer is option D. Correct answer is option D. Next problem. Question number 12. Question number 12. If A and B are two events and A and B are non-empty sets, A is not equal to 5, B is not equal to 5, then so P of A bar B is P of A into P of B. No, that is not the formula. P of A bar B is equal to P of A intersection B upon P of B. Yes, second one is formula correct. P of A bar B into P of B bar A is equal to 1. It is wrong. P of A bar B is equal to P of A into P of B. So A and B, A and D are both the same. So the correct answer is option B. The right formula for probability of the event A given that B is already occurred is probability of A intersection B upon probability of B. The correct answer is option B. Next problem. If A and B are events such that P P of A is equal to 0.4, P of B is equal to 0.3 and P of A union B is equal to 0.5. Then probability of B dash intersection A is. So in this question we need to find probability of B dash intersection A. This is the A event and this is the B event. We are finding B dash intersection A. So B dash intersection A will be the region A minus B. This is nothing but B dash intersection A, it is equal to A minus B, or we can write this as A minus A intersection B. Therefore, the formula to find P of B dash intersection A is equal to P of A minus P of A intersection B. First, we need to find the value of probability of A intersection B. The formula is probability of A plus probability of B minus probability of A union B. So, in the question number 13, the given probability of A value is 0.4 plus probability of B value is 0.3 minus probability of A union B is 0.5. It is equal to 0.2. Therefore, probability of B dash intersection A, it is equal to P of A minus P of A intersection B. The value of P of A is 0.4 minus 0.2. It is equal to 0.2. 0.2 is nothing but 1 by 5. Therefore, the correct answer is option D. For the question number 13, the correct answer is option D. So 14 and 15 all are same problems. So let's do the question number 16. Please try the question number 14 and also 15. They are almost all easy questions. Next, question number 16. Question number 16, it is exactly similar to question number 13. So question number 16 is, they given P of A value, P of B and P of A intersection B. We need to find probability of A dash bar B. So we know that probability of A bar B plus probability of A dash bar B is always equal to 1. Therefore, probability of A dash bar B, it is equal to 1 minus probability of A bar B. That is 1 minus, the formula to find probability of A bar B is probability of A intersection B upon probability of B. They given probability of A intersection B. So probability of A intersection B is 4 by 13 upon probability of B value is 9 by 13. So this 13 get cancelled. We will get 1 minus 4 by 9. Take the LCM, simplify, we will get 5 by 9. Therefore, the correct answer is option D. The correct answer is option D. That is the value for question number 16. So question number 15 is, already I told you the formula for probability of A dash bar B dash. Answer is 1 minus probability of A union B upon 1 minus probability of B, or 1 minus probability of A union B upon probability of B dash. For the question number 17, answer is option C. Question number 18. If A and B are two independent events with P of A is equal to 3 by 5 and P of B is equal to 4 by 9, then P of A dash intersection B dash is. We know that if two events are independent events, then their complements are also independent events. Question number 18. They already given that A and B are independent events. If A and B are independent events, then A dash and B dash are also independent events. So its formula is equal to probability of A dash into probability of B dash. The formula to find probability of A dash whenever they given probability of A, it is 1 minus probability of A into 1 minus probability of B. So P of A value is 3 by 5, 1 minus P of A value will be 2 by 5, P of B value is 4 by 9, 1 minus P of B value is 5 by 9. It is equal to 2 by 9. For the question number 18, the answer is option D. The correct answer is option D for the question number 18. Next problem. Question number 19. If two events are independent, then they must be mutually exclusive. It is not at all necessary that if two events are independent events, they are not at all necessary that both events must be mutually exclusive. The statement first A is incorrect. It is wrong. Option B, the sum of their probabilities must be equal to 1. It is not at all necessary. Both A and B are correct. Since already the statement A is wrong, therefore option B is also wrong. Therefore the correct answer is none of above. None of above. Our option is D for the question number 19. So question number 20 is, it is very easy problem. So P of A bar B and P of A dash bar B, easily you can find that value. So take the question number 20 as homework. Question number 21, it is again a simple formula. If A and B are independent events, then P of A intersection B is equal to P of A into P of B. For the question number 21, answer is option C. For the question number 22, if two events E and F are independent, if P of E is equal to 0.3, P of E union F is equal to 0.5, then P of E bar F minus P of F bar E is. Again the given data is not sufficient because they did not given the value for probability of F value. So question number 22 is wrong. Okay. And please remember, whenever they given statement question, please understand the problem. Afterwards you have to apply the suitable formula, then you have to find the answer, because from the question number 23 all the questions are statement questions, and please be careful while solving any of the statement question. Question number 23. A bag contains 5 red and 3 blue balls. If 3 balls are drawn at random without replacement, the probability of getting exactly 1 red ball is. Exactly 1 red ball is. So there is a bag. So in that bag they given 5 red balls. 5 red balls and 3 blue balls. 3 blue balls. So and from this bag we are selecting 3 balls. Therefore the required probability is, the sample space is, how many ways we are going to select 3 balls out of this 8 balls. It is 8C3. So we can select 3 balls from 8 balls in 8C3 ways. Among that, the given event is exactly 1 is the red ball, only 1 is the red ball. So out of 5 red ball we have to select any 1 red ball, and from the remaining 3 blue balls you have to select any 2 blue ball. because we are selecting 3 balls. Therefore, the value of 5C1 is 5, the value of 3C2 is 3. We know that NCR is equal to NC n minus R. So, 3C2 is equal to 3C1, that is equal to 3. The value of 8C3 is 8 into 7 into 6 by 3 into 2 into 1. So, 3 to the 6 and 6 get cancelled. We get 5 3 is 15 upon 8 7 is 56. Therefore, the correct answer is option C. For the question number 23, the correct answer is option C. That is the required probability. Next problem. Question number 24. Question number 24. 3 persons A, B and C fire at a target in turn. Starting with A, their probability of hitting the target are 0.4, 0.3 and 0.2 respectively. Then what is the probability of 2 hitting the target is? Listen. So, there are 3 persons A, B, C and each one is hitting the target. Therefore, hitting the target by individual persons is an independent event. The question is, what is the probability of hitting the target exactly by 2 persons? That means, if A person, B person hit the target, C person does not hit the target. If A person, C person hit the target, B person does not hit the target. Therefore, the required probability is, so the person A will hit the target, person B will hit the target, person C does not hit the target. We call C dash. Or person A will hit the target, person C will hit the target, but person B will not hit the target. Or person B will hit the target, person C hit the target, person A does not. So, they given that P of A value is 0.4, P of B value is 0.3, P of C value is 0.2. Therefore, P of C dash is 1 minus 0.2, that is 0.8, plus P of A value is 0.4, P of C value is 0.2, P of B dash, since P of B is 0.3, therefore P of B dash will be 0.7, plus P of B value is 0.7 into P of C is 0.2 into P of A dash. P of A value is 0.4, so P of A dash is 0.6. Simplify all the values, you will get 0.188. Therefore, the correct answer is option B. This is the required probability. You have to simplify, multiply and you just add all the values, you will get the value 0.188. So, the correct answer is option B. Next problem. Question number 25. Question number 25. Assume that in a family each child is equally likely to be a boy or a girl. That is, probability of giving the birth to a boy or it may be a girl. It is same. A family with 3 children is chosen at random. The probability that the eldest child is a girl, given that family has at least one girl is a child. See here, this problem is based on conditional probability. Please look at that, the second sentence. We need to find probability that the eldest child is a girl, given that the event is already occurred that the family has at least one girl. Family has at least one girl. See here, the given event is given, this event is already occurred. So what is the given event? The given event is family has at least, family has at least one girl. A family has at least one girl. So we know the meaning of at least. It may be one or it may be more than one. So what are the possibilities? It may be, so girl, boy, boy, are, boy, girl, boy, are, boy, boy, girl, or it may be girl, girl, boy, are, girl, boy, girl, are, boy, girl, girl, are, all are girls. 4, 5, 6, 7. So number of elements in the event A, it is equal to 7. For which event we have to find the probability? We have to find probability for the event the eldest child is a girl. Eldest child, event B is eldest child is a girl. Eldest child is a girl. Eldest means the first child is a girl. So what are the possibilities? It may be GBB, it may be GGB, or GBG, or it may be GGG. So which are the commons? A intersection B. The common are GBB, GGB, GBG, GGG. Therefore, the number of elements in an event A intersection B is equal to 4. The question is, we have to find probability of the event B given that A is already occurred. It is equal to probability of B intersection A upon probability of A. This nothing but n of A intersection B upon n of A. It is nothing but n of A intersection B is nothing but 4 upon n of A, it is equal to 7. Therefore, answer is 4 by 7. Answer is 4 by 7. Yes, the correct answer is option D. D is the correct answer. So this problem is based on conditional probability. Next problem. Next question. A die is thrown and a card is selected at random from a deck of 52 playing cards. Then the probability of getting an even number on the die and a spade card is. So in this question there are two events. One event is they are throwing a die and also they are taking one card from the pack of 52 playing cards. So here there are two events. One is throwing a die, other one is drawing a card. So these two events are different events. So these two events are what? Independent events. Therefore, this problem is based on independent events. So they given that, just assume that event A1 is stand for getting an even number. Getting an even number on throwing a die. On throwing a die. And E2 be an event. The event is selecting a spade card. Selecting a spade card. So here these two events are independent events. Here events are independent. events are independent. That is, occurrence of one event does not affect occurrence of another event. Therefore, we need to find probability of getting an even number and selecting a spade card is equal to probability of E1 into probability of E2. So whenever we will throw a die, we get totally 6 outcomes. Out of that, getting a even number, there are only 3 possibilities. It may be 2, it may be 4, it may be 6. And from the playing cards, there are 54 playing cards. After that, there are 13 spade card. It is equal to 1 by 2 into 1 by 4. It is nothing but 1 by 8. Therefore, the correct answer is option C. Option C is the correct answer for the question number 26. Next problem. This is the answer for question number 26. Next problem. Next, question number 27. Question number 27. A box contains 3 orange balls, 3 green balls and 2 blue balls. 3 balls are drawn at random from the box without replacement. The probability of drawing 2 green balls and 1 blue ball is. So in this question, there is a box. So in this box, there are 3 orange balls. There are 3 orange balls and there are 3 green balls. There are 3 green balls and there are 2 blue balls. There are 2 blue balls. So from this box, we are selecting 3 balls. Therefore, the required probabilities. So total number of balls is 8. Out of 8, we are selecting any 3 balls. This is the number of elements comes under the sample space. Out of that, 2 are green balls and 1 is blue ball. So there are 3 green balls. Out of 3 green balls, we have to select any 2 green ball and the remaining ball will be blue ball. So out of 2 ball, we have to select any 1 blue ball. So 3C2 is equal to 3 into 2C1 is equal to 2 upon 8C3 is 8 into 7. We get 2 1s are 2 4s are 8 is equal to 3 by 28. Therefore, the correct answer is option A. For the question number 27, the correct answer is option A. Question number 28. So, question number 28. A flashlight has 8 batteries, out of which 3 are red, 3 are dead. If 2 batteries are selected without replacement and tested, what is the probability that both are dead is? So, here we are selecting 2 batteries without replacement, means first we are taking the one battery, we are testing whether is it working or not. Then we are taking the second battery without replacing first battery by any other battery. Therefore, selecting the battery one after another without replacement is an independent event. So here just find probability of first battery is a defecting battery and you should go for intersection. Second battery is also defected. It is a independent events. Therefore, the probability of first battery is a defected battery. There are 3 are dead battery. So we can say 3 by 8. The probability of selecting first dead battery out of 3 is 3 out of 8. It is without replacement. Then the remaining dead batteries are 2 because already we selected 1, remaining is 2 out of 8 batteries already we choose 1 battery, remaining is 7. That is 2 ones are 2 fours are 8, you get 3 by 28. Therefore, the correct answer is option D. For the question number 28, the correct answer is option D. Question number 29, this problem is based on Bernoulli's trial. You don't have the Bernoulli's trial, please don't do the question number 29. Question number 30. Question number 30. Two dice are thrown. Whenever you throw two dice, the total outcomes we will get is 36. That is 6 square, 36. They are like 1 1, 1 2, 1 3, 1 4, 1 5, 1 6, 2 1, 2 2, 2 3, 2 4, 2 5, 2 6 up to 6 1, 6 2, 6 3, 6 4, 6 5, 6 6. So we get totally 36 outcomes. It is known that the sum of the numbers on the dice was less than 6. Then the probability of getting a sum is 3. Again, this problem is based on conditional probability because it is known that this event is already occurred, that sum of the numbers on the dice was less than 6. So less than 6 means it may be 5, it may be 4, it may be 3, it may be 2, or it may be 1. Therefore, assume that A be a event that the sum is less than 6. Sum is less than 6. That is, the sum may be 5. To get 5, it may be 2 comma 3, 3 comma 2, or 1 comma 4, 4 comma 1. The sum may be 5, 4 comma 1. There is another possibility, or the sum may be 4. If it is 4, it is 2 comma 2. There is no any other possibility. No, it is 2 comma 2. It may be 1 comma 3, 3 comma 1. That is 4. It may be 3. If it is 3, we get 1 comma 2, 2 comma 1. It may be 2. That is 1 comma 1. There is no any other possibilities. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So number of elements present in the event A, it is equal to 10. For which event we have to find the probability? The sum is 3. So B is the event that the sum is 3. Sum is 3. The order by which comes under the event B are 1 comma 2 and 2 comma 1. That is A intersection B, it is equal to 1 comma 2, 2 comma 1. Therefore, we are finding probability of getting the sum is 3 given that the sum is less than 6. It is equal to probability of A intersection B upon probability of A. That is, number of elements which are common among the events A and B upon number of outcomes present in the event A. It is equal to 2 by 10. That is nothing but 1 by 5. The correct answer is option C. For the question number 30, the correct answer is option C. Next, again question number 31 is out of syllabus. It is binomial distribution. You don't have the concept of binomial distribution. Next, question number 32. Two cards are drawn from a well shuffled deck of 52 playing cards with replacements. The probability that both cards are queen is. So in this question we are taking two cards, one after another with replacements. With replacement means whenever you selected one more card, on that place you have to place one more card. Means still total number of cards in the pack will be the same. In that, what is the probability of taking 2 queen cards? Therefore, question number 32, the required probability is equal to probability of, so taking first card as a queen card and taking second card also a queen card, and we are taking the card one after another with replacement is an independent events. Therefore, probability of selecting first queen card into probability of selecting the second queen card. Out of 52 cards, 4 are queen upon 52 and 4 are queen out of 52 because it is with replacements. It is equal to 1 by 13 into 1 by 13. Therefore, correct answer is option A for the question number 32. Next, here the question number 33, 34, 35, 36, 37, all the problem based on Bernoulli's trial and also random variable. You don't have concept of Bernoulli's trial and also random variable. I am not going to teach all these problems. Straight away you can do the problem of question number 39. Even question number 38 is also, it is not in the syllabus. Question number 39. So, in a college, 30 students fail in physics, 25 fail in mathematics and 10 students fail in both the subjects. One student is chosen at random. The probability that she fails in physics if she has failed in mathematics. So, this problem is based on conditional probability because they given that she has failed in mathematics, means we have to find what is the probability of the randomly selected student failed in physics given that she already failed in mathematics. This is the answer for question number 39. So, this is conditional probability. It is equal to probability of the student failed in both physics and mathematics upon probability of the student failed in mathematics. That is, the number of students failed in both the subjects is 10 and number of students failed in mathematics is 30. It is equal to 1 by 3. So, the correct answer is option D. The correct answer is option D. Next, move on to the next problem. Question number 48. The probability of all three digit numbers having all the digits are same is. So, we have to find probability of all 3 digit numbers having all the digits are same. So, we know that to form any of a number of any number of digits, we have to use the digits 0, 1, 2, 3, 4, 5, 6, 7, 8 and also 9. So, therefore, the number of the sample space will be the number of 3 digit numbers, the number of 3 digits number. So, we are going to find the number of 3 digit numbers by using permutation. So, to find a 3 digit number, the 100 place cannot be 0, it must be non-zero. So, there are 9 non-zero digits. I can choose the 100 digit in 9 ways. It is 9 ways. It is 9 is not a digit, 9 ways means it may be 1, it may be 2, it may be 3, it may be 4, it may be 5, it may be 6, it may be 7, it may be 8 or it may be 9. But 10 and unit digit may be any of the number, but here we are finding all the 3 digit numbers. I can choose the 10 place and unit place in 10 ways. I want digit in unit 10 and also 100 places. So, number of outcomes comes under the sample space is 900. After that, all the digits are same. Assume that in the event all the digits are same. All the digits are same. Therefore, number of elements comes under the event E is equal to 9 because it may be 1 1 1, 2 2 2, 3 3 3, 4 4 4, 5 5 5, 6 6 6, 7 7 7, 8 8 8, 9 9 9. 0 0 0 is not a 3-digit number. So, we get 1 up from 1 to 9. Therefore, the required probability P of E is equal to 9 by 900, it is equal to 1 by 100. The correct answer is option A. The correct answer is option A. This is the answer for question number 48. Next problem. Question number 49. Question number 49. Three numbers are chosen at random from 1 to 20. The probability that they are consecutive is. So, here how many ways we can select three numbers from 1 to 20. Therefore, the number of elements comes under the sample space is, there are 20 digits, out of 20 we have to select any 3, that is 20 C3. The value of 20 C3 is equal to 20 into 19 into 18 divided by 3 into 2 into 1, that is 6 3s are 18. It is equal to 20 into 19 into 3. Out of that, for which event we have to find the probability? They are consecutive. Therefore, what are the possible elements comes under the event E? So, we have to select three numbers, they are consecutive numbers. It may be 1 2 3 or 2 3 4 or 3 4 5. It will goes up to 18, 19, 20. Therefore, number of elements comes under the event E. It is equal to 18. Therefore, the required probability is P of E, it is equal to N of E by N of S, that is 20 into 19 into 3. So, 3 1s are, 3 6s are, 2 3s are, 2 10s are. It is equal to 3 upon 190. So, the correct answer is option C. Correct answer is option C. Next problem, question number 50. So, this is the last problem, and please try to solve the remaining questions and take the remaining questions as homework. Question number 50. 12 tickets are numbered from 1 to 12. One ticket is drawn at random. Then the probability of the number to be divisible by either 2 or 3 is. So, they given totally 12 tickets. Therefore, number of elements comes under the sample space is equal to 12. So, here we are finding probability to an event that selected number is either divisible by 2 or 3, but not both. Therefore, so which are the numbers which are divisible by 2? Divisible by 2. They are all even numbers. They given the tickets 1 to 12. So, take only the even numbers 2, 4, 6, 8, 10 and also 12. And take the tickets which are divisible by 3. Divisible by 3. So, multiple of 3, 3, 6, 9 and also 12. So, take the numbers which are divisible by either 2 or 3. Divisible by 2 or 3 means we have to leave the common elements. The common elements are 6, and also 12. The remaining are 2, 4, 8, 10, 3 and also 9. Therefore, the required probability is there are 6 numbers out of 12. That is 3 2 is 6, sorry 6 1 is 6, 6 2 is 12. Answer is 1 by 2. This is 12. This is 6. This is 3 2 is 6, 3 4 is 12, or it is 2 by 3. See here, in this question, the numbers which are divisible by 2 or 3 means you have to apply the set theory. We will get the concept of n of A plus n of B minus n of A intersection B. So, total numbers minus you have to neglect the common elements only one time. So, we get 2, 4, 8, 10, 3, 9 and take the common elements only once, that is 6, 12. Therefore, the number of elements which are divisible by 2 or 3 is equal to 8 out of 12. Therefore, 4 2 is 8, 4 3 is 12. So, answer is 2 by 3. The correct answer is option A. So, 2 or 3 means you have to apply the concept of the number of digits divisible by 2 plus number of digits which are divisible by 3 minus number of digits which are divisible by 2 and also 3. This gives number of digits which are divisible by either 2 or 3. So, we get totally 8. So, 8 by 12. So, 4 2 is 8, 4 3 is 12. So, the correct answer is option A. So, these are the some questions for the CET point of view. Please practice the remaining questions also. Thank you, students.